Welcome to the third video in the P2 binomial theorem chapter. On the screen is a starter question to review the formula from the last video, but it is also an introduction to the idea in this video that you don't always need to do the full expansion. In this case, we only need the first three terms. Be careful you're aware of ascending powers of x and descending powers of x in terms of what you will get if you use the a to be the 3, or if you use the a to be the minus 2x. One of these will give you descending powers of x, the other ascending powers of x. So just keep an eye out for those words. In this case, I'm using n equals 15. The a will be the 3 to get ascending powers, and the b will be minus 2x. I won't always write this out, but just to make it clear what I'm putting into the formula. So our three terms, a to the power of n, which is 15, plus 15 choose 1, which is 15, times a to the power of n minus 1, which is 14, times b to the power of 1, plus 15 choose 2, I don't know that off by heart, so onto the calculator, is 105, times a down a power again, n minus 2 is 13, times b squared. So here I have three terms, the first three terms in ascending powers of x. Just to be formal, I'm going to put a plus dot 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 there to show that I understand it does go on, but I have deliberately stopped after the first three. Now here, I'm not going to simplify this. Be aware of what the question wants you to do. 3 to the power of 15 is a very big number. It may be that you are required to simplify, but it may be that you can leave it in index form. Even if you were to leave it in index form, I guess we should simplify the other bits. So 3 to the power of 15 plus 3 to the power of 14 times, oh, I've done a plus there, that should be a minus. This would be why you should simplify the other bits. Minus 3 to the power of 14 times 30x. And then this will be a plus again. So we've got 105 times 2 squared, which is 420. So 3 to the power 13 times 420 x squared. So even if you leave some of it in index form, maybe do as much simplifying as is reasonable. And then of course, plus dot dot dot. Although you can probably see from the pattern here, that plus will actually be a minus if we were to do the next term. So there are the first three terms in ascending powers of x for this expansion. So the key point here is that you won't always need the full expansion. Sometimes only the first few terms, sometimes only one specific term. And understanding what the question wants will determine how many terms you have to calculate. Here, I've highlighted in green what is called the general term in the formula. We start with the first term, or the zeroth term, if I want to keep my numbers correct with these numbers. First term, second term, and so on, down to the final term. And then in here, there's the many, many terms depending on your expansion and the general term. So this general term here can be very useful for finding one specific term. But you have to be careful you know what number r is in order to find the correct term, the term that you actually want. So an example of that is find the coefficient of x power 4 in the binomial expansion of 2 plus 3x all to the power 10. So I'm going to use this general term. But to use this general term, I need to know n, r, a, and b. Now a and b, let's stick with the fairly normal. A is 2, b is 3x. We know n is the power on the bracket, so that is 10. The question is, what is r in order to get the term that I want, the x power 4 term? And in this case, it's probably fairly instinctive because of the patterns that you've seen in previous questions. But just to highlight how I'm going to go about doing this if it isn't a very obvious one, I look at which of my 3 have got x, or more to the point, which of my 2 in the bracket has got an x. That's the b term. It's an x power 1, which won't always be the case in more complicated questions. But in this case, the b term is 3x. So to get an x power 4, I want my b term to be to the power 4. And here, that means r will be 4. So if I work with r equals 4, it should give me the term I want. And if you're not entirely sure, but you think it's right, just go for it, and you'll see from your answer whether or not you've got the right term. And if you haven't, for some reason, then you can go back and adjust your r to find the one that you do want. So deciding what r is, we can now use our green general term to find out the coefficient. So n is 10, r is 4, so it's 10 choose 4, times a, which is 2, to the n minus r, so we've got 10 minus 4, that's 6, times b, 3x, to the power of r, which is 4. A quick check here is that the n minus r and the r, if you put them together, n minus r plus r obviously should always take you back to n. So 6 plus 4 is 10. So if you ever get these two numbers not adding to n, you've made a little mistake. Okay, 10 choose 4, I don't know what that is. Onto the calculator. 10 choose 4 is 210 times 2 to the power 6, which is 64, times 3 to the power 4, which is 81, and x power 4. So to get my coefficient, that's 81 times 64 times 210 is a very large number, 1088640. So that's 1,088,640 x to the power 4. And if I was being very formal, it doesn't actually ask for the term, it asks for the coefficient. I would put a little sentence or note on the end if you've got time. Therefore, the coefficient of x to the power 4 is this number, without the x power 4. And that is our final answer to this question. So this green term here, it won't be highlighted in green in the formula booklet, obviously, but it will be in the formula booklet. This is a powerful tool. It's the general term. A slightly more complicated question. Find the coefficient of x cubed in the binomial expansion of this. Well, we have an expansion we can do here, but then there's also a multiplying bracket in front. So on the surface you might think, oh well, we'll just find the x squared term in here and multiply it by x. But be careful, because the x cubed term in here multiplied by the 2 will also give you an x cubed term. So there are 2 x cubed terms that we will need to add together. So breaking it down a little bit, I'm going to find the first few terms here, because I'm going to need at least 2 of them. So I'm going to expand this in the usual way up to x cubed, and then I'll take those few terms, multiply it by this bracket, and then pick out all of the x cubed terms I've got at the end, add them together, and that will be my coefficient. So a quick explanation there, let's go through it. So for 3 minus 2x to the power 7, if we apply the binomial theorem, that is 3 to the 7 plus 7 choose 1, which is 7, times 3 to the 6 times minus 2x plus 7 choose 2, onto the calculator. 21 times 3 to the 5 times minus 2x squared. And you can see in this example, I've skipped most of the background ideas. I've just gone ahead and thrown all the numbers into the formula. The more questions you do, the easier this becomes. And that gives me an x squared, but I want x cubed, so I'll do one more. 7, choose 3 on the calculator is 35, times 3 to the power 4 times minus 2x cubed plus dot dot dot, to show that I understand the expansion continues, but I don't really care about the other terms, because any terms above this that get multiplied by a 2 or an x will be higher than I want. So I could even see in this case, I don't really care about this one or this one. They won't get me an x cubed even when multiplied by an x, but this one will when multiplied by x, and this one will when multiplied by the 2. So I want this times x plus this times 2. And those really are the terms that I'm interested in. So I'm going to change slightly what I was going to do. I was going to do the whole expansion and up to this point and then simplify and then multiply by the bracket, but actually I'm just going to pluck these out. I'm going to do 21 times 3 to the power 5 times, let me square that, that's a 4x squared. And this term from the binomial expansion times x from the bracket in front will give me one of my x cubed terms. And then to that I want to add the other one, which is 35 times 3 to the power 4 times minus 2x cubed, that's minus 8x cubed. And this term multiplied by the 2 in the front bracket will give me an x cubed term as well. So these are the only terms in this entire expansion that will generate an x cubed term. So these are the two that I want based on the question I'm trying to answer. So here I'm going to have to put this in my calculator because they want the number 21 times 3 to the power 5 times 4 is 20,412 x cubed. And here 35 times 3 to the power 4 times minus 8 times the 2 on the end is minus 45,360 x cubed. And so long as I haven't made a mistake, my final answer there, 20,412 minus 45,360 is minus 24,948 x cubed. Therefore, therefore the coefficient of x cubed is minus 24,948. And that should be our final answer. Okay, final example in 2 parts. Part A, write down the first 3 terms in ascending powers of x of the binomial expansion of 1 plus qx to the 8, where q almost obviously is a non-zero constant. That is just a formal addition on the end there, because obviously if q is 0, then it doesn't matter what x is. This is all 0, and 1 to the 8 is just 1. So that's a little bit of formality that you might see in a question that doesn't really matter, because that's quite obvious. Okay, first 3 terms, just plug it into the formula as normal. The fact that we've got a q instead of a number, don't worry too much about that, just go through the usual process. So we've got 1 plus qx to the power 8, following the formula at the top here, where the 1 is the a. That's 1 to the power of 8, which is just 1, but for an exam, I would put that power 8 on there first, simplify it later so the examiner can be clear that you understand what formula you're using and how. Plus 8 choose 1, which is 8 times 1 to the power 7. Put brackets in there just to make it clear that's not an 8.1. And then I need to times that by qx to the power 1. So there's the first 2, I need one more. 8 choose 2 on my calculator is 28. Times, again, just for formality's sake, so you can see what I'm doing, and so the examiner could see what I'm doing in a test. Put all of that in there. And that will give us a 1 plus 8qx plus 28 times 1 is 28, and then q squared x squared. And these are the first 3 terms. So that's part A finished. I've gone across the page because part B is coming up underneath here. Oh, I would have had room. Never mind. Given that, in the expansion of this that we've just found, oh, let me do a little plus dot dot dot. So in the expansion of this, which is up here, the coefficient of x is minus r, and the coefficient of x squared is 7r. Find the value of q and the value of r. So this question is leading us through to the point where we can create simultaneous equations, because we know the coefficient of x up here is 8q. And they're telling us here the coefficient of x is minus r. So 8q must be equal to minus r. Remember, if we're talking about coefficients, nowhere in this question, part B, should we see an x. Just the coefficients. So I guess you could write 8qx equals minus rx, but that's unnecessarily complex. So let's just say 8q, the coefficient of x is minus r. And then we have a second piece of information to create our second equation, and that is that the coefficient of x squared, 28q squared, is equal to 7r. So 28 q squared is equal to 7r. Find the value of q and the value of r. So I've done most of the hard work here. We did the expansion in part A, and we formed our simultaneous equations from the information given in part B. All I need to do now is to go ahead and solve these. So here, if I know that 8q is equal to minus r, there are different ways we can do this. Shall we square all of this? No, let's just say r is equal to minus 8q and put that in here. So we've got 28 q squared is equal to 7 times r, which is minus 8q, so minus 56q. If q is non-zero, then I can cancel a q on both sides, and I can say that, let's put this over here. So we've got 56 divided by 28 is 2, so q is equal to minus 2, because I've cancelled that with that, and then just divided by 28. And if q is equal to minus 2, put that back in there, and we can see very quickly that r is equal to 16. Now, assuming no silly mistakes in my process, these are my two answers. The value of q, minus 2, and the value of r, 16. So this video showing you that you don't always need the entire expansion, which in turn means you should be very careful to know what the question is asking you to find, so that you don't do more work than is necessary, and that you don't do the wrong work compared to what is necessary to find the answer. In the fourth video, the final video, we'll look at one last little thing. For now, you can practice these ideas using the Edexcel International Textbook, exercise 4D. and hopefully I will see you in the final video.